Alright, so we're going to be going through and squaring up the dogs on a double end tennoner. Now I don't have my normal camera set up today because it was left back at the hotel, so please bear with me that I'm doing this with not my normal camera setup. I'm also not using my tripods, my microphones, the whole 9 yards, so please bear with me with that. So what we're going to do is we're going to be setting up the machine so that when we are looking at the dogs, that the dogs are cutting square. So when we are talking about square, it's important that we understand that we are talking about square as far as a 90-degree corner. If I can get this cap off, come on. Not quite got my dexterity back in that finger yet. So when we're talking square, we are talking about 90 degrees. Can't write with that finger either. So we're talking about 90 degrees here. We're not talking about the physical shape. So if it's a rectangle, as long as we got 90 degrees square, that's what we care about. So when you hear us referring to square, 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 it's not a physical shape, okay? So the way that we tune these machines is that we want to go in and we want to test it against itself. So I have gone in previously, and I think the other technicians, you can see multiple identifications in here, where they've gone in and they've numbered these things from 0 to however many there is, and on this particular machine it's 18. So we need to have a starter position, which on this particular one is a number 1. Sometimes when the Italians do it, and when I follow up behind the Italians, we notice that the number 1 position is actually 0, because for whatever reason they like to start with 0. It doesn't matter, as long as we identify 1 and that becomes the starter dog. Then we process that part through the machine twice. So we got one panel that is marked as a 0 and a 1, and what this does is this identifies how it's passing through the machine. So it's going through, and the 0 side this time was related to the dogs. The number 1 side and its mate was what's being trimmed off. And I have a second panel that's exactly the same. 100% duplicate, laid out the same, everything is 100% the same. Process it through on dog number 1, you let dog number 1 come back around, stop the machine, load the second panel, send it through, no adjustments to the machines, no changes, no nothing. Then you take those panels and then you lay them up in the machine and you book match them. So the question is where are we going to book match them at? Now here, I'm not going to show you around because this customer doesn't particularly care for camera, so they're being patient with me. So I'm trying to be respectful to not to span the camera around in circles on us. So what we want to do is we want to see the relationship of where the dog lands on the board and then how far out of square it is when we're doing that. So let me see if I can zoom out this a little bit. I think that's better. If I come over here to my chain, I have the exact relationship of my dog and my dog. So what I want to do is get my panels, lay my panels on there. But sometimes these track pads are deteriorated, so referencing the track pad is not a good idea. So I'm fortunate that my Allen keys are circles and they're precision ground on it, so that they're true shafts. If you don't, you can cut off a couple drill bits, use drill bits, but what we're wanting to do is elevate the part. We're going to lay the part on there. We grab this and we're going to book match these so that my number 0, which is reference to my dog, is on there. And again, sorry, doing this one-handed with an injured hand on top of everything else. Get that laid in there. This is much easier with 2 hands. It's also much easier when you're trying not to film it. Come on, get in there. Now, the way that this is setting right now, it's setting on the pins, which is my keys, and that has elevated it up. Let me see if I can get around from the back side. You can see it. See where I'm elevated? I'm elevated. I do that because then any blemishes I have across the bottom of my parts is irrelevant. I have now taken it and I've slid it back over here to the side where I'm pulled up against the same fence that I referenced. So the relationship of my keys is the same relationship of my dogs. Okay? And since I book matched them, brought everything to this side, now here's my error. So because I have book matched it, my error now becomes double. So if I go up here and I measure this error, whatever this is, and then I check that back against the registers of the dogs, then that tells me how far I'm out. I know that the spacing between my dogs, because I measured it, is roughly about 290 millimeters, and that's where I drew my line. I come up to this, I measure here at 290 millimeters, and I was 0.35 millimeters error between these two surfaces. So it was out of square, 0.25 millimeters. This panel was canted this way, this panel was canted this way. So what that tells me, let me split these out and get rid of this first panel, is that my error is actually 0.175, and my part is laying in this way, which means as it's going in the machine that it is too far like this. So what I need to do is then advance forward this dog 0.17 millimeters, and that part will be square. Okay? Now typically, not always, but typically we don't test these back against the fence. But the way that this machine is set up and the security fences and everything that's around this, if I do this one dog at a time and I book match this, I'm going to be here for hours and hours and hours. So what we're going to do is we're going to correct this number one dog. I'm going to retest the part. After I run this through and that error on my number one part is nullified, so it's almost down to absolute nothing, then I'm going to bring it up here to where my saddle is at here, because on this particular in-feed fence I only have one saddle. So I'm going to come up here to where my saddle is at with it on the dog, and I'm going to take a feeler gauge and find my error from front to back, and then advance each dog up to match that, and then use that as my reference to set it. Once I get those referenced and set, then I will go through and confirm each one after that randomly, although they're all very, very close, but we got one or two in here somewhere that's off just enough to drive the operators crazy. All right, so that's how you do it. It's nice and simple. Book matching it, find your error, split your error in half. That's your adjustment. The trickiest part is to figure out whether or not the parallelogram has got to be adjusted back to the right or just to the left to be able to counter for your dog position. That's the worst part about it. All right. All right, so we have tuned the number one dog, and I have a setting on the table over here. It's a mate panel to it. This number one dog took me a couple times to run it through because, you know, as we do when we get older, I ran it through the wrong way. So I cut 2 on the number 0, which screwed my test up, so I had to repeat it. But now the number one dog was the 0.17. The register amount on these registers I thought was 1 millimeter per rotation. It's actually 0.5 millimeters, so I had to go 2 facets on the bolt. But I seen that as soon as I seen the threads, I recognized my values. So I made one adjustment, sent it through, sent it on its mate sides, brought it back over here, tested them. They are absolutely dead on square to the point that I cannot measure them with even the instruments that I carry. I did set up the 290 millimeters. That is our distance from dog to dog. Put that back on here. Now what I've done is I've come over to my saddle, straddled my saddle because that takes the flex out of this part of the fence. I'm on my saddle, and I went through and I found with the feeler gauge which one it was that drug up to this line, so I'm using that as a reference point. When I come up to here, I find that, and this is a 0.23 millimeters, so that when I advance my next dog up, which will be dog number 2, I'll set that relationship to the same there. Dog number 3, dog number 4, dog number 5, repeat till it's done. Okay, so I have my primary point out here, my secondary point, either or. This could be primary, this could be secondary. Your tertiary is your fence. Okay, so I don't care if it touches here and not here. If it touches here, it doesn't here. I need to know what that error is. Once I know what that error is and I have a place to reference against, you'll see on the fence I've got a mark. As long as I'm here and my chain is in good shape, which I'm questionable about these chains, this gives me a starting point. Once I go through and attune each fence to that, each dog to that relationship, I will then confirm each dog. So I'll pull a panel out, I'll mark it as panel number 2, 0 and a 1, and that's going to be for dog number 2. I'll do 1 for 3, 1 for 4, 1 for 5, all the way through it, and I will test each one doing the mirrored profile. Now whether I process two panels per dog, or if I use one of my master panels to compare it against. Depends on the reaction from my first couple dogs that I do. So if the chains are in really bad shape and I'm comparing it against a master panel, it won't be as accurate. So if I have to go in and I've got really bad chains, I may wind up running a pair of panels per dog. But typically I can get away with using a master panel, and then my error, instead of being split by double, is just a singular, but it gets me done twice as fast, okay? And depending on the quality of the chain, whether or not the chains, how much life is on them, and what the customer does, sometimes it doesn't justify the extra effort. Well, that's it. That's all there is to it. It's a nice and simple adjustment. Like I said, it's very tedious because you're dealing with sub-fractions of a millimeter, and you are going into that. Sorry, I had to flip the machine in manual. You're going in and you're doing all these adjustments off of points that you can't necessarily measure routinely. Okay, so it's difficult to measure, it's difficult to do the math, and sometimes you try to figure out if your panel is canted to the right, canted to the left. You always adjust it the wrong way. No big deal, you just undo it. Okay, another advantage is just that we're talking about this distance on here, knowing what this distance is. If I know what the error is, that 0.17 millimeters that I had up here, I know what the thread pitch is on my register down here, and if I got a 1.0 millimeter thread pitch and I've got a 0.17 millimeter error, then 1/7 of a turn is 0.17, excuse me, 1/6 of a turn, one facet of the Allen key, 1/6 of a turn is 0.17. So as long as I know all my math and I know my metrics, which is why metric is superior to SAE measurements in this application, it makes the adjustments of the registers much simpler. Okay, that's it. Hope you find it interesting. As always, guys, be safe out there. Wear your PPE, lock out, tag out, the whole 9 yards. And as always, be safe. Let's go make a million.